I am Evgeny. I work at a consulting company in Israel called Devops. I just got the domain name, so why not call this the company name? And we go to startups and big companies, and we consult about all the things that you heard today. And what I want to talk to you about is a bit about unit testing, but before I'll talk about unit testing for infrastructure, I need to kind of remind ourselves what infrastructure is, a bit of history, give an example of a tool that we can use, and I hope this will be brief. Nice. So what is infrastructure? Infrastructure, usually when people in technology talk about it, it's the servers, right? It's the configuration of the servers, it's the application running on the servers, the services, it's all kinds of tunings, patches, and maybe in the cloud, it's the servers themselves, because that can be API provisioned. And in the cloud, infrastructure might look like this. You might have like an auto-scaling group that creates more and more servers via API calls, and all kinds of other helpers like load balancer and DNS and databases and et cetera, et cetera. Now, for a simple web application, this is pretty simple, and configuring a server in the old way used to be like, okay, I have a server, I just run some commands, and it's configured, and that's it. But today, we have some more complex problems. For example, a couple of years ago, I think in 2008, there was the Obama election campaign. Anybody knows this project about it? Some nods, one hand, okay. And it looked like this. This is the whole Google map, and just this part you can see here. And every part here is a bunch of servers without scaling groups. Now, creating something this complex requires you to run fast, never redo your work, never get regressions, and to have some kind of automated configuration. So you might notice that they have Puppet on every group. So basically, they wrote the code. Now, if this code doesn't work somewhere, and in many places, they might be in trouble. So they need to keep up the quality very high. Another example is Netflix. Netflix have their servers added and removed depending on the amount of requests they get per day. So Netflix is a video streaming service. Every evening, people come home, they start watching Netflix movies, and they do API calls, and Netflix need more servers to handle the load. They look at the CPU graph more or less, and based on that, they can decide how many servers they need. And this blank space is the money they saved, because this is servers they didn't have provisioned, okay? And the provisioning is, of course, automatic. So once upon a time, not so long ago, there was this guy called Mark who decided there are so many flavors of Unix, and to configure all these flavors of Unix, it's so different, and writing actual scripts to configure them is so hard, that I would create an engine, and he wrote a couple of doctor papers about it, that will allow me to use a domain-specific language called CF Engine at the time to define the configuration of the servers, and it would work the same across all operating systems at the time. Today, this is less of an issue, actually. So configuration management systems like CF Engine, Chef, and Puppet are a bit less required, but people use them still, especially in large enterprises where you saw the graph, they are like kind of far away from the current practice of Docker and whatever. And around the same time, system administrators would configure the servers manually. They would create servers by hand, so to speak. And some smart people wrote that this is how cars used to be created a long time ago, but today they have standard tooling, so cars are created the same every time. And this standard tooling, for example, today in system administration is maybe Docker. So we are getting there, but we'll still not. We're still kind of stuck in the 1900s of the car making industry if we talk about how we create servers today. And this leads to problems. What kind of problems? People creating servers is not very efficient, because people are not very good at doing repetitive things, okay? This is an example of a downtime of a service. I think it's the Xbox service. Now, you know these downtimes happen every month, every week, even, for all kinds of services. And most of them are caused by some human error, some mistake that could have been avoided if they have tested their steps, if they haven't done their steps manually and done them automatically. And several companies don't exist anymore because of manual steps done on servers, which is a shame. Our friend DevOps Borat says 5% of DevOps have infrastructure as code, and the rest, 95, have infrastructure as PowerPoint. And I think I have a couple of slides where they actually check this, but the answer to not do manual steps is automation. You all know this, right? Automate everything. They did a zero turnaround. The company did a survey a couple of years ago, and they asked, what do you actually use to be more productive? And most people use shell scripts and maybe VI and stuff. But the more interesting metric is this. Which percent of your infrastructure is actually written as code? And only 10% of companies said that more than 90% of their infrastructure is automated with code. And most, 61% of companies reply that they do this by hand. And this leads us to the question at the beginning of today, what is the operations team? Operations teams are the people who do things by hand. Where do they usually live? They usually live in enterprise companies that we just saw about. The same companies also said which automation tool they prefer. This was about 2 years ago. I think today Docker would be the first one because that's how the buzz works. So I want to give an example of what Chef is. Who knows Chef? A lot of you. So okay, so I'll be brief. So Chef is an open source. It configures servers. It has all these names that are very hard to find in Google. And it's written in Ruby, more or less. And it looks like this. I want to install a package. I want to make sure this package service will be running. And maybe I want to change the configuration. I can provide some variables and attributes from outside that I can configure this configuration. And then when I run it like this, Chef Solo, and I give it like a couple of files that say what to actually run, it will tell me it installed the package, and it says it didn't do anything with the service. It didn't start it or anything, but the configuration was the same as it should be, and nothing was done. And if I want to do a small change, make a small change, if I run it again, sorry, it's idempotent. What idempotent means, you run it again and again and again and again, doesn't do anything. This is fast. It doesn't say the milliseconds it took, but it was like immediate, which is good. And then when I change something in the attribute file, I run it again. It changes the configuration file for Redis, and it also restarts the service, which is again good because this is exactly what we wanted to do, and it's all automatic. Of course, here I only installed Redis, but this could install hundreds of things with thousands of configuration files. It doesn't really matter. But, sorry. But this is code, okay? And what if you have mistakes here? You didn't write, I don't know, you wrote mode 0644 without the quotes and without the zero, okay? That would be a bug because that would be decimal and not octal. Now, developers found a way to handle bugs, handle regressions, handle higher quality while you move forward, and that thing is called unit tests. Who here wrote a unit test in his life? Who here writes unit tests all the time today? None. So I guess you're all operations people, and this is a good talk for you. You should learn from developers. They can make their code work better over time and not come back and repeat and fix regression bugs. How can a unit test look like? This is an example of BATS, Bash Automated Test System. You just write this in a file and you run it with the BATS command, and it would check the exit code, the return status of the command, and maybe the output and the standard error, etc., etc. So it's pretty simple. It's not rocket science. Now, what is test-driven? Test-driven in development, again, usually means write the test first, see that it fails, right? The red, see that it fails. Write the implementation, see that it passes, and if you can see a better way to write this with less lines of code, less complexity, then you can refactor your code. Now, there are all kinds of names for tests, like what is a unit test, what is an integration test, what is a... Okay, I don't want to go into naming because that everyone has a different idea of what is a unit test and what is not a unit test. So let's just say they're important, and this guy, Jeff Atwood, is one of the guys who wrote Stack Overflow, so you should probably know him. And it says this is so important that it should be first-class citizen, like if or like for loop in a language. You should have unit tests. This is how important this is. And in Ruby, which is used by Chef and by Puppet, you have lots of options to write unit tests for Ruby code, and some of them have been adapted to work with Chef and with the infrastructure. Actually, there are a lot of testing frameworks in Ruby. These are just the 3 popular ones. So if you have a Ruby class, this is the scraper class. It accepts a web page and then it goes and fetches it and writes it into a file, right? You can write a unit test in Ruby that will make sure that the URI was parsed and the file read should match some kind of text that you know exists on the internet on that website. So this is a simple test, but it's not a unit test. Why is it not a unit test? Mainly because it's slow. Also because it requires an internet connection. And you want your test to give you immediate fast feedback, right? Immediate fast feedback means they would still work even when you don't have your office Wi-Fi working, which happens to all of us. And it's very fast. And also, when you run it multiple times, it doesn't behave differently every time you run it, okay? And of course, if it depends on the internet, it would behave differently. For example, here, if you change the web page, this would start failing, which is like, okay, but I don't control the web page. I only control my code, and I only control my tests. I don't control what is on the web page. Okay, so let's define what a unit test is. It tests small things, not large systems, usually. It controls the data coming in and coming out of the test. Of course, it relies on your code, and it checks that your code is fit for use. It checks that your code actually does what it promises to do. And the advantages of having unit tests, as I already mentioned, it finds problems early. You don't need to get a report from the production that you have just uninstalled OpenSSL instead of fixing the Heartbleed bug. It helps you change things and test them, well, before you deploy to production. It also actually helps with learning the system, learning how it works. Learning Chef, for example, is much more fast when you write unit tests. It's also a kind of a documentation for your infrastructure if you write it in a way that can be parsed by humans. And it helps you with designing better, more refactored systems. Again, if you add the extra effort. Now, how do you use testing in Chef? So to make error is human, to propagate error to all server in automatic way is DevOps, which is why you should have some tests for Chef. And there are lots of options, again, here, which you can choose the most fitting one. There's a book written by a very great guy from the UK who just quit this field because he fed up with all the people who don't want to write tests, I guess. And he wrote Cucumber Chef. Anybody knows Cucumber? Some people? It's a very textual, human-readable way of writing tests. It's very verbose as well. I'll show an example. There's also Chef Spec, which checks that Chef actually does what you want it to do. And there's a test kitchen that can run integration tests. It can also run in Docker and Vagrant and in your cloud or whatever, and test across multiple operating systems like Ubuntu and CentOS. Like, what operating systems do you have now? So how does Chef Spec look like? You just say, I want to make sure that my Chef code includes this include recipe Nginx thing. You don't test that Nginx was installed. You just test that you didn't forget to include whatever third-party code that does what it is you need to be done. And you also want to make sure that that code installs the package Nginx, because this is why you ran this. So this is simple enough. You can write these tests, run the test, see that it fails, add this line, and see that it passes. And then whenever somebody merges your code and breaks it and removes this line by mistake, maybe they will not remove your test, and the test will show them that they did something wrong. Cucumber Chef, much more verbose, as I said. You write like, I won't even read this, but you write scenarios with given when and then, given when and then you run them, and on the side you have this code that actually, given a regular expression, writes what needs to be tested for each of these lines. So usually given are a setup, when are something that you apply, some code that you run, like you run your chef, and then is the assertion of the test. And you implement these using either a chef spec or server spec or Minitest that we will see in a second. Minitest is a standard Ruby library today, starting from a 1.9, I think. And there's a Chef Minitest wrapper that gives you a lot of extra properties you can use, and it integrates well with Chef. With Chef. So for example, you can check the node properties like this. You can either use the spec format with describe and it and should, or you can use the test case format which is an inheritance of a test case, and then you have assertions. And of course, things like run status and node are Chef specific. And a very nice thing that is not really coupled to Chef, you can use this with other tools as well, is Kitchen. Kitchen.ci is a website that integrates a lot of testing frameworks and runs them in a loop for the operating systems that you tell it to. So if you say, I want to have Docker Ubuntu, and in that Docker Ubuntu, this is the folder with all my tests, run my Chef recipes and then run my tests, it would do all the integration tests. So this is like the BATS test we showed before that checks that Git is installed. You run it, it brings up a new Ubuntu server or Docker container and gives you a result if it failed or didn't. And of course, BATS is more verbose. You can check the output, you can check lines, etc., etc. I won't go into syntax because if you choose to use this is very similar to shell scripting. As you can see, it looks more or less exactly like shell scripting. Last but not least, server spec. Server spec is again a Ruby library that is based on RSpec, but it provides a lot of testers. Like it can check if a package is installed. It doesn't need Chef for this. You can install a package using Ansible or a shell script, but this test will test that the package is installed. This test would test that the service is enabled and running with the check config and the service start. This checks that a port is in listening mode, and etc., etc. So it's pretty simple, just 3 lines, and you know that you have your service listening on the right port. And not unit testing, but good practices for writing code for your infrastructure. Like in regular programming languages, you have lint, which checks that you wrote your code correctly and you adhere to some coding practices. There is Food Critic for Chef. There is Puppet Lint for Puppet. I think there's something for Ansible. And they have lots of rules like this that say, don't do this with an explanation. This is the best place to go and learn Chef, for example. So you can actually go here and see, aha, in Chef I shouldn't do this, I should do this, and it includes most best practices and things that are not apparent to a new user of Chef or Puppet or whatever it is that you use. And there are more tools. Some of them are up to date, some of them are not. I don't want to go into them much, but they all try to make this process much faster and less complex for people to use. Okay, thank you very much.